All right, so guys, shh. All right, so my screen looks a little bit different than yours, but you should be in the 4.3 Delta Math. All right, we're gonna do that first single problem, which happens to be that first problem on your worksheet. So we're gonna work through some of these together, and then once we get answers, you can type them into Delta Math as we go. All right, so all right, so I'm mainly going to be writing on the worksheet, but just know they're the exact same problems as your singles in Delta Math. All right, they're the exact same problem for everyone. So as I'm doing this work, you guys should also be working it out as well. All right, so first off, number one. So we did a couple of these yesterday when you did your task sort. These are actually considered a little bit easier than like the big ones we did yesterday on the green graphic organizer. The hard part is that it's not like with the common denominator where you just look and see what you got and then you just don't write a repeat. It's a little bit different. You actually kind of have to do it like the numerical ones where you find a number that they can both multiply to or value. So first off, if you have a value that does not have a denominator, what should you do? Since we're messing around with fractions, put it over 1. So it's first things first, because we're dealing with fractions. If you don't have a denominator for one of them, put it over 1. All right, just so you know that you still got to handle the fractions. Now, to find a common denominator, now I'm not saying least common denominator, because honestly, when you're dealing with the monomial ones, if you just get a common denominator, I'm happy. The easiest way to get a common denominator for monomials, just multiply them together. So take your two denominators, multiply them together. So what's y cubed times 1? Y cubed. So that's what we're going to try and get both of our fractions to. So this should be y cubed minus something y cubed. Now, our first fraction already has a denominator of y cubed. So what goes on top? X. Nothing changes from the first fraction because it already has that common denominator. Now, what do I need to multiply to the top and bottom to make the denominator of 1 become y cubed? So what do I need to multiply to 1 to get y cubed? Y cubed. So multiply the top and the bottom by y cubed. So what's xy times y cubed? Yep, xy to the fourth. So remember, you multiply exponents of like bases, all you got to do is add them. So I just got to add the 1 from the y to the 3 from the y to get y to the fourth. Now, we're not going to do any simplifying because if we do, we'll just end up with what we started with. But what can I do now once I get to this step? They're the same denominator. What can I do? I can combine them. So in other words, I can get them into one fraction. So this will be x minus x y to the fourth. Now, we may look like we're done, but we still got to check to make sure that if we factor that numerator, nothing crosses. All right? So how can I factor the numerator? What's the first thing you always look for when you factor? Greatest sound factor, so GCF. So, what's my GCF for the numerator? X. Good. So if I take an x out of both, that means I would have x times 1 minus y to the fourth all over y cubed. Now, technically we can factor 1 minus y to the fourth again because it's a difference of squares, but if we look, we're not going to at any point get y cubed outside of anything. So or any y's outside of anything. That's not connected by a plus or minus. So do you guys think just from here I can simplify anything? Cross anything, I mean. No. Because remember, we can't touch this 4 because the minus is married, we can't touch it. So because of that, and we can't, and even if we go a step further with the simplifying, it still won't give us anything viable. We'll just be wasting our time. We're done. All right. So your answer is this. So if I go ahead and put that into Delta Math, it's that very first adding and subtracting. Just type it in exactly as we got it. So x minus xy to the fourth all over y cubed should be correct. So type in it exactly how we got it. All right, any questions on number 1? All right, let's look at the second single problem, so the next one under it. So this is number 2. So number 2 on your worksheet, same thing as the second single. All right, so remember, to get a common denominator, the easiest way to get it is just multiply our two denominators. So what do you think a common denominator for this one would be? And let's go with Lainey. So what would my common denominator be here? 45 what? 45x, not squared, cubed. So all you gotta do, now this is not the least common denominator, so we'll have to do a little bit more simplification, but again, for these, when in doubt, just multiply them. All right. This means you'll have to do a little bit more simplification at the end, but you know what? You guys seem a bit more comfortable with the simplifying than with defining the common denominators. Okay. So we're going to try and turn our factors, not our factors, our fractions, to have a denominator of 45x cubed. So let's go with Jackson. What would I need to multiply to the top and the bottom of the first fraction in order to get 45x cubed on the bottom? So we're starting with a 15. What do I need to multiply to that to get 45x cubed? 3 what? 3x cubed. Good. So we're going to multiply the top and the bottom by 3x cubed. So Jackson, what's 4 times 3x cubed? 12x cubed. Good. All right. Now let's go with... Shouldn't be. Hold on. All right, Zach. So what I need to multiply to the second fraction to get 45x cubed on the bottom. So this is our current denominator. What do I need to multiply to it? 15. So 15 over 15. So Zach, what's 4 times 15? Yeah. So once we get here, we can write it as one big fraction. Now, we're not done because we need to check to see if we can factor the numerator any. So let's go with Caden. So Caden, if I'm just looking at the numerator only, so the top, how could I factor that? What do I always look for first?
Sorry, what you said?
So how can I factor this numerator right here? What do you look for first? Always.
GCF?
Is there one?
No.
Yep.
There is one. Yeah, there's one.
So what number can go into both 12 and 60?
6.
Higher.
12.
Yep. So there's a GCF of 12. So, Caden, if I divide both these terms by 12, what am I left with? So don't worry about the 45. That stays as it is. But just the two terms on top.
We wanted
So it would be 12 outside and then x cubed plus 5. Now, the x cubed plus 5, we can't simplify anymore. We're done. But what part could I simplify here? What could simplify? Doesn't have to necessarily be something we cross out. So anyone, what could we simplify? Right. We can simplify 12 over 45. So if it helps, write it as a separate fraction. And like Dylan said, you can divide it by 3 over 3, and that'll give you 4 over 15. So we're going to take this 4 over 15 and replace the 12 over 45 with it. So this will be 4x cubed plus 5 over 15x cubed. And since there's no way we can cross out anything else because there's either pluses with it or they're just simplified completely, we're done. So this would be your next one. So you should get 4 times x cubed plus 5 and then over 15 x cubed. Yeah, so all they did was they distributed the 4 back. That's the only difference. But as long as you get to its most simplest form, they don't really care if you distribute it back. And remember, I don't care either. So I just want it in its simplest form. If you distribute that,
That's the
yeah, because if you distribute it again, that's fine. Or if you use 15x cubed, you can do that too. Because 15x cubed is actually the least common denominator. So you wouldn't have had to simplify if you did that. All right? So that's the same thing. So yeah, Zach brought up a good point. If you look at how Delta Math did it, their common denominator was 15x cubed. That's actually the least common denominator. All right? Like I said, you can get a common denominator by multiplying the two denominators, but it's no guarantee that it's the least. But it doesn't matter. As long as you have a common denominator, you can make it work. You just may have to do a little extra simplifying. All right? Either way, you still get the exact same thing. Wake up, sleepy babies. Take them hoods off. All right, so take a couple of minutes. Try number 3 on your own. You can check yourself by putting it into Delta Math. So I'll give you guys about 7 minutes.
I think I got it.
already did it. No.
Oh, that's the part.
Raise the bathroom.
just want to make sure that I'm on top of it. Can't wait till break. I just want to make sure I'm on top of it.
I really have to go.
Yeah. Okay. So everyone's trying number 3 on their own, and again, use Delta Math to check yourself. So if you don't get it right the first time, I would put it in the second time. Six, right? I wasn't paying attention.
Yeah. Like good ones. What were you guessing?
So now I never wait, you're the sex. It's so funny. Because I told him two other things. He said this. Yeah, and then he said it again today, and it was still wrong.
So get stuck, talk to your roommates.
I'll show you. Me and her were friends on TikTok. I literally no, he had me like a wave whenever he called me.
Now just combine all the information.
I'm actually friends with him.
What? Yeah, the same answer.
Pretty much, you just have to take it.
No, it did not.
Thankfully, I'm not full-time.
Nine plus the index.
Yeah.
Q over 6x squared.
Alright, 9 plus 8
Remember, you ask yourself, what is this denominator? What do I do? Like,
What was it? 9
Q.
same thing with you.
I would just so much.
Then just use it at night.
No, I don't know it.
Whatever.
Oh, you're
My mom found out.
No, I don't want to. I don't want to. 200 from
So 2 times 3 is 6x cubed. Then you multiply this by 2x cubed, so that's 8x.
Yeah.
So you understand what you did wrong?
Yeah.
So rewrite 2x. Alright guys, it looks like most of y'all are pretty much done, so I'm gonna go ahead and call it. But alright. So walk me through it. So let's go with Frederick. So Frederick, first off, what's my common denominator? Good. So 6x squared. So if I'm using 6x squared, let's go with Julian. So Julian, what do I need to multiply to the first fraction to get that denominator of 6x squared? 3. Good. So what would your new numerator be? 9. And then Julian, what do I have to multiply to the other fraction? So what might new numerator be? 8x what? Cubed. Good. All right. Now from here, your last step is just combine them into one fraction. So they all have the 6x squared. So we can just write it as one big fraction. Then, does 9 and 8 have anything in common, GCF wise? Nope. Because of that fact, and there's no x with the 9, we're done. So that's literally your answer. So if you put it in, you should get it correct. So that means that the other 3 sections of adding and subtracting you should be able to do. That first section is similar to the 3 that we just did. The other 2 are similar to what we did on the green sheet yesterday. All right. Now, the next thing we're going to do, and we haven't talked about this yet, is complex fractions. Now, complex fractions are essentially a combination of adding and subtracting and multiplication and division. So we're taking both concepts that we've learned already and putting them together. Now, the reason I call it complex is if you look at 4 through 6, number 4, for example, complex fractions means you've got fractions within fractions. All right? So double the fractions, double the fun. Woo! Now, it's actually pretty easy to take care of them. Okay? So, one way that you could do it, and I don't recommend this way, is you could simplify the numerator and denominators on their own, like by doing the adding and subtracting first and then divide them. I wouldn't recommend that. It takes too much time. My recommendation is find a common denominator that you can multiply to all 4 baby fractions and essentially eliminate the denominators. All right? So, how I do this is, and this is on your Delta map, it's the first one that's labeled complex fractions. That's So, I'm going to do this first one, explaining it. The next one we'll kind of do together, and then the last one I'll have you guys do on your own. So, yeah.
Can I put it to business?
Not this.
No.
So, you can do it if it's multiple choice, but not if it's not. I'll explain the multiple choice cheat later. Anyway. So, what we do first off is we're going to look at all of our denominators. So, all your baby denominators. So, with that 1, what's technically the denominator? 1. So, we're looking at all 4 of these little baby denominators. I call them the baby denominators because those are our baby fractions. They're little tiny fractions within the big fraction. All right? Now, the way we find a decent common denominator is essentially the same thing that we did on our green sheet. So what did I say you do to find a common denominator when we did our green sheet? So when you factor the denominators and you found the least common denominator, how would you typically do that? So for example, you don't need to write this down. If you had 1 over x plus 4, x plus 5, plus 2 over x plus 4, x minus 2. We're not solving this, but what would your common denominator be? So x plus 4 is part of it. What else? X plus 5 and x minus 2. So what did we essentially do?
Right now.
We wrote down the denominators except the double. All right. We're going to do the same thing here for all 4 of them. Now, if you notice, they're multiplying together. Same thing with these. They'll multiply them together. So if I look at all 3 of my baby denominators, what would I write down to multiply together? So it's one of the denominators. Denominators. So 9 is one of them. What else? 3x. And what's the last one? 1. And since the 9 repeats, we don't have to write it twice because we want it as small as possible. So, guess what my common denominator is if I multiply them together? 27x. So, this is what we're going to be multiplying to the top and the bottom in order to get rid of our baby denominators. Okay? Now, I recommend writing this separately and label exactly. All right? So, this is all about precision and having neat work because it's a lot. Trust me. So, I'm going to separate these individually. So, I'm going to do numerator on its own and then denominator on its own of the big fraction. So let's do the numerator first. So everything we're doing is going to be related to the numerator. So I'm going to take that 27x. I'm going to put it over 1. Because I want to multiply that whole number of 27x, not 27x over 27x, because we'd just be multiplying 1 to it. All right, which does nothing. And I'm going to do 1/9 plus 1 over 3x. So I'm multiplying it to my entire numerator. Now, how do I multiply fractions? Just straight across. So we distribute the 27x to my 2 numerators and the 1 to my 2 denominators. So what's 27x times 1? Guys, 27x times 1. 7x. Thank you. So that'll be the same for both. And then 1 times anything is itself. This is 9. And this is 3x. Now, what do you notice about these 2 fractions individually? Put off, please. We could do what for both of them? Simplify. We can simplify these 2 fractions individually and essentially get rid of the denominators. Because what's 27x divided by 9? 3 what? 3x. That denominator's gone. What's 27x divided by 3x?
1.
Well, the x's cancel. So what's 27 divided by 3? 9. So the x's cancel. I'm left with plus 9. So this is now my new numerator. Now, because we have to do some simplifying, and we already know how to simplify a rational, we're just going to go ahead and factor it so we don't have to do it later. So if I want to factor 3x plus 9, what's the only way I can factor it? By taking a GCF of 3. So I have a GCF of 3. So if I divide both these terms by 3, this would equal 3 times, and what's left? X plus 3. So this right here is my new numerator. Now we're not going to write the fraction yet because now I want to do my denominator, but just note that this is what we're going to replace with this when the time comes. Any questions on what I did with the numerator? All right, now we're going to look at the denominator. So we're going to do the exact same thing that we just did with the numerator, but with the denominator. So everything we're going to do here is with your denominator. So I got 27x over 1. I'm still multiplying that least common denominator, or the common denominator, to x squared over 9 minus 1 over 1. So remember, you're just distributing numerator to numerator, denominator to denominator. So what's 27x times x squared? 27x cubed. Remember, there's a 1 here. You would add the exponents. 27x times itself is 27x. So, but make sure you put that minus there. Then, if we divide it, or no, many fractions, multiply 1 by anything, 9, 1. Now we're simplifying. So 27x cubed over 9 simplifies down to what? 3x cubed. 27 divided by 9 is 3. And then you slap on the x cubed. 27x divided by itself is? Or divide by 1? It's 27x. Make sure you got that minus in front of it. So denominators are gone now. Now I can just factor it so that I don't have to do it later. So what can I factor out of each of these? So what's the first thing you're looking for? What do we always look for? GCF. Do I have one? 3 what? 3x. They both contain at least one x, and they both can be divisible by 3. So I'm going to divide both of these by 3x. I'm left with 3x times, what's 3x cubed divided by 3x? What happens to the 3's? Cancel. So what's x cubed divided by x? X squared. What about 27x divided by 3x? Negative 9. These x's cancel out, so you just have 27 divided by 3. That's a 9. Now, we're not done factoring yet because what's going on with those parentheses right there? What do I have? So what's in the parentheses? What's going on with these? They're what? What's this? X squared minus 9, also known as a what?
Oh, a difference of squares.
The difference of squares, so we got to factor it again. How do I factor a difference of squares? Square root the first and the second. Write one with the minus, the other with the plus. Square root of x squared is x. Square root of 9 is 3. So this is 3x, don't forget that GCF, times x plus 3 times x minus 3. So this right here is what we're going to write in place of our original denominator. So now that I've got both kind of simplified down as best as I can get, I'm going to rewrite it as the fraction. So I'm replacing the numerator with the numerator, the denominator with the denominator. So my new fraction will be 3 times x plus 3 all over 3x times x plus 3 times x minus 3. Now what do you notice? X plus 3's, they're gone. What else? The 3's are gone too. We got one on top, one on bottom. Nope. So what am I left with? If I crossed out everything on top, what do I have to put as a placeholder? A 1. And then what's left on the bottom? And x minus 3. So guess what? That's my answer. So again, it's a lot of steps and it can get confusing. But if you just make sure you're organized and just do numerator by itself and denominator by itself and then put it back together at the end, it's a lot less confusing. All right, but you actually got to take the time to do that process. All right, so you can put that into your delta math and it should be correct. So again, I would go ahead and put it in your delta math so you don't have to worry about it later. It's freebie points. All right, now, next thing we're going to do is we're going to do another one, but we're going to do it together. So I'm going to call on you guys to kind of help me fill in blanks. All right. So let's look at number 5. That's that second one down that says complex fractions. First off, in that numerator, just the singular x. What do I have to put underneath it? A 1. So guys, just right off the bat, make sure you got 4 denominators. You don't put one under the one that's not a fraction. So, same process. We're going to start by looking at our individual baby denominators. And we're going to do the list them all except for the repeat. So, let's go with Peyton. So, Peyton, if I'm looking at all 4 of my baby denominators, which of them would I list? 1, 3, and what? X. Good. So we're going to do 1 times 3 times x, which, Peyton, what is that? 3x. So 3x is what we're going to be multiplying to our numerator. It's also what we're going to be multiplying to our denominator. So now I'm going to separate them. So my numerator, you can just make a note to yourself. Denominator, I want to do the numerator first. All right. First things first, we're multiplying by 3x over 1. 2 x over 1 minus x squared over 3. So what's my next move? Let's go Skylar. So once I'm here, what's kind of your gut instinct? What should you do? You can distribute. So we multiply numerators by numerators, denominators by denominators. So Skylar, what's 3x times x? 3x what? Squared. And then 1 times 1 is just 1. And Skylar, what's 3x times negative x squared? Negative 3x to the what? Cubed. Remember, you just add the exponents, so 1 plus 2. And then 1 times 3 is just 3. Now we can simplify these fractions. So let's go with Dylan P. So Dylan, what's my first fraction? So the 3x squared over 1, what does that simplify to? Yep, 3x squared over 1. Yep. What about the 3x cubed over 3? Negative x what? Yep. 3's cancel out, you're just left with the negative x cubed. Now to finish this up, we're just going to do some quick factoring. So let's go with Lainey. So Lainey, how would I factor that? You always start by looking for what? Do I have one? Yeah, we do. What is it? So not 3, because we don't have 3's in both. But what do we have in both? An x what?
Square.
Squared. We have at least 2 x's in both. So my GCF is x squared. So if I divide both these terms by x squared, so Lainey, what am I left with after I take out the x squared? 3 minus what? X. Good. X squareds cancel, and then 2 of the x's cancel from the x cubed, so it's just x squared, or just a singular x now. So this right here is my new numerator. Now, we're going to do the same thing with the denominator. So we've done the numerator, now we're dealing with the denominator. So I'm going to set it up the exact same way. So still multiplying by 3x over 1, but now we're multiplying it to x over 3 minus 3 over x. So we start by distributing. So what will we get? Let's go with Jordan. So if I distribute the numerators, what would I get up top? 3x squared, then what's negative 3 times 3x? So 3x times 3. Negative 9x, good. All over, multiply anything by 1 itself, so 3 and x. Now we can simplify our fractions. So how would I simplify those fractions, Mackenzie? So the first fraction, 3x squared over 3, how can that simplify? What can I cross out? So just this first fraction, or this one. What can I cross out? The 3's are gone. So I'm left with an x squared. What about the second fraction? X's are gone, so I'm left with minus 9. Now, not quite done yet because we got to factor it, but what is this? It's a difference of squares. And if you look at our previous problem, we already factored an x squared minus 9. So we're just going to recopy that answer. So we know that x squared minus 9 is exactly the same as x plus 3 times x minus 3. And again, the only reason I'm not going through how to factor that is we factored it already in the previous problem. So this is now my new denominator. So my last step is write them out back in as the fraction. So this would be x squared times 3 minus x all over x plus 3 times x minus 3. Now, at first glance, can I cross anything out? What do you guys think? Yes, no, maybe? I can't cross anything out just yet. Because why can I not cross out the 3 minus x and the x minus 3? They're not the same thing. If you rewrote it, putting the x first in the top, this would be x squared times negative x plus 3, because you got to keep the signs consistent, all over x plus 3, x minus 3. However, I could make this look like this. How would I have to do that, though? Right. So, guys, if you ever have a situation where you just need the signs to flip so you can cross something out, just pull a negative out. So this now becomes negative x squared times x minus 3 over x plus 3 times x minus 3. Now we can cross out our x minus 3's. And we're left with negative x squared over x plus 3. Nothing else cancels, so we're done. All right. Any questions on this one? All right. Now, next thing you're going to do, I want you guys to try number 6 on your own. So work it out on your own. You can talk to your teammates if you like. I'm going to leave this one up as a sample. So I'll leave the work up for this one as a sample. So if you guys want to do this like in terms of steps, common denominator, step 1. Doing everything with the numerator, step 2. Step 3 is everything with the denominator. Step 4 is putting them back in the fraction and start crossing stuff out. If you want to do it by steps, that's another way you can think about it. And make sure you're organized. So, give you guys about let's say, let's just go 10 minutes. Try that problem. So everyone's attended name number 6. So guys, make sure you copy this work down because that's pretty much your cheat or your notes for the rest of the complex fraction sections. You have to do some on your own later. All right. Then. So,
So I'll separate these two fractions.
so make sure you put the plus in the so you know that they're separated.
So you just combine them or you cancel out?
You cancel first. So look what I did for step 2. What I do before I combine.
Why is there a second set of numbers? Why does it say equal to?
Because that's the fractions that I got before I started canceling. But the divide by x squared, that goes with the GCF.
So I cancel these two out?
So you cancel out the x squareds, which will leave you with how many x's left.
Wait, what?
So so you had 2x cubed over x.
Yeah.
Right, just look at it individually. So don't worry about the sum. What can I cross out?
Yes, trust me.
On the x. So what are you left on top?
2x squared. Okay.
What about the second one?
2x squared. No, 2x.
Right, because 2 of the x's will cancel. Then you would factor this. That makes sense?
4x.
And backwards. So GCF.
Oh. Okay.
Make a little bit more sense?
Yeah.
Have it over?
Yeah, no. Yeah.
I know what the fuck is it.
I know how to do it. What kind of I'm gonna hate it.
I would literally try to 2x2 and parentheses x. And then don't distribute.
I have a question.
Uh-huh.
Did I got 2x and it's coming back here now. What? So do I do it to the denominator too?
Well, no.
Switch
Just remember, everything you're doing right now is in the numerator. You're not doing this. That's why I say separate this so there's no problem. So if you divide both of these by 2x, what are you left with? 2x on the outside.
X.
And
2. It would be
without
nothing.
2.
No.
What else do you have? So that's your factor. And you do the same thing for denominator. So start with multiplying your common denominator. And then, so that's why I said do it separately so you don't confuse yourself. The only parts where you're actually doing something involving both at the same time is the first step and then the last step. The in between, there's well, I thought that
You know, you're I mean, come on. Money. No. I can be at 45 by then. If I wanted to.
I hope you make that use. That's I don't know what
The weights. He misses those weights. Thursday, Friday. The thing is, there are some teachers I have like not a crush on. I didn't know. I didn't know where. Yes. Yes.
what are you talking about?
the two X's that you see.
So you're a snowboarder?
Yeah, no chance for tripping.
What are y'all talking about?
No, they were not like this. Somebody that no, they were like this.
Okay, so
This thing is somebody yes, they have.
He tried to do the dance with the expert. Why do you not want to do that? I got like happy with you. So, she just gets to walk out and use the bathroom. It's
I used to say like this. It's based on
grape, cherry, strawberry, watermelon.
because you have to so like
Yes. Tomorrow we in turn.
You're gonna have to look I'm like in a dairy. You're gonna have to like pour it out. With like water and shit. The water with the rice, either flavor has to get it.
Oh no, it's
And you don't it's not covered.
can you don't know it's covered.
It's new like
These are crumpets.
you don't have to know. That's like
No.
don't distribute. Just write as 2x cubed times x plus 1 because you'll be able to see where it crosses. All right, guys. So even if you're not done, that's okay. We're just gonna go ahead and go through it. At the very least, most of y'all got through simplifying the numerator. All right, and the denominator, I can see giving you trouble. So if we're looking at this, so we're looking at number 6, numero 6. Let's work together on this. So let's go with Leslie. What did you find to be your common denominator for all of your baby denominators? 2x cubed. Good. So if you do my method of list all of your denominators except a repeat, if there is one, and then multiply them together, you do 2 times x cubed, not x cubed, x squared. So that'd be 2x cubed. All right. Now, we're now going to do our numerators and our denominators separately. So numerator, I'm going to multiply 2x cubed over 1 to the entire numerator. So this would give me, if I multiply top by top, bottom by bottom, this would give me 2x cubed over x plus 2x cubed over x squared. Now the reason I did that is because we're essentially just multiplying everything by 1 in some shape or form, so not really much question to ask with that. So now let's go with Alexis. How would I simplify the first fraction? So the 2x cubed over x. Uh-huh. Right, so the x goes away. We can take out 1x from both the top and the bottom. So if we take 1x from the x cubed, what does that leave me with, Alexis? Right. So this would be 2x squared. Because remember, if you take 1 from each, the top and the bottom, you just take 1 off the exponent. And Alexis, what about the second one? Mm-hmm. Right. So this become x to the first. If we took 2 x's away, so this would be plus 2x. All right, now we're in factor land. So let's go with Dylan L. How would I factor 2x squared plus 2x? So this would be GCF of 2x, which gives me what? Good. So I now got my numerator done. We're going to do the same thing for the denominator. All right. So now, I meant to put a plus. I screw up sometimes if I don't pay attention. So, denominator. All right, same thing. 2x cubed over 1, multiplying it to x minus 1 over 2 minus 1 over x. Now, I'm assuming that the x minus 1 kind of threw you a little bit. If it helps, put parentheses around it. And here's my kind of tip. Do not distribute. All right? So you're literally just going to write it as straight up multiplication, but you're not going to distribute yet. So when we do multiply top and bottom, this will be 2x cubed times x minus 1. I'm not going to distribute. 1 times 2 is 2 minus 2x cubed over 1 times x, which is x. And the reason I don't distribute is because now it's really, really easy to see what I need to cross out for that first fraction. All right. So what can I cross out for that first fraction, Layla? So for this first fraction right here, what can I cross out? Not the 2x cubed, but I could cross out the 2's. So the 2's are gone. So this would be x cubed times x minus 1. Still not distributing yet. And then Layla, what can I cancel out from the second fraction? The x. So if I take 1x from both, what does that 3 become? Squared. So minus 2x squared. Now we can distribute. So I'm going to distribute the x cubed. So I get x to the fourth minus x cubed, and then you bring down the negative 2x squared. Now we're in factoring land. So if I'm talking factoring, what am I going to do first, Wyatt? So you always look for what first? Do I have one? Yes. So I have a GCF of x squared. So if I take out the x squared, Wyatt, what am I left with? So in other words, you're just subtracting 2 x's from each. Good. Now, that trinomial I can also factor, so you can do a quick big X. So negative 2 on top, negative 1 on the bottom, which the only factors of negative 2 are 1 and 2. Which one has to be negative? 2. So the negative has to be the 2, and if you do the snowflake, just write the AX on top. So this would be x squared times x plus 1 times x minus 2. Now it's fully factored, so this is my entire denominator. Now, our last step is to write our numerator and denominator back into our fraction and simplify. So, I have 2x times x plus 1 over x squared times x plus 1 times x minus 2. So, what can I cross out, Tyreek? So, what can I cross out with that big fraction?
X plus 1.
Those are gone. What else can I cross out, Tyreek?
X.
So I can cross out one of the x's. So what am I left with on the bottom? How many x's?
3, 2,
If I take 1 away.
1.
1. So I'm left with 2 over x times x minus 2. And that's it. All right, so here's what I'm going to do, because we actually finished earlier than my first class. So for the rest of class, you guys got a solid 25 minutes? I'll give you that time to work on the rest of this delta math. So you should have all the singles done. The other 3 sections, there's like 5 per section. Those are on your own. If you already did it, if you have another delta math that you need to do, you can work on that, or you can work on your journal, or whatever you need to do. Okay? Or optional work, whatever. I was about to say, I'm going to let you go on break first, and then you guys come back. That's what you're doing. So I'm setting the timer for 3 minutes. Make sure you're back. No walking the halls.